Okay, so let's continue with our next coding exercise series. So open the leetcode.com and go to the problems tab. And in the search question number 74, hit enter. So there is a question, search a 2D matrix. It's come under the medium category. So click on it. So let's read the question. So you are given a m cross an integer matrix with the following two properties. So we have some matrix given. Matrix means we have some rows and we have some columns. Each row is sorted in non-decreasing order. Non-decreasing means like increasing order, basically ascending order. Each row is sorted. So every row is sorted. So if you even see the diagram, so 1, 3, 5, 7, these are in sorted order. 10, 11, 16, 20 sorted order. 23, 30, 34, 60 sorted order. First integer of each row is greater than the last integer of the previous row. So first integer of the each row. So let's suppose we take the second row, 10, is greater than the last integer of the previous row. So previous row is the row number 1 and this is the row number 2. So 10 is greater than 7. So these are also sorted. Given an integer target, so we have some target is given. Return true if the target is in the matrix or otherwise false. So if you just read this question till this point, we will see like it's a very easy category question, because we have some target given and we need to find whether the target exists in this matrix or not. If it is exist, then we return true. If it doesn't exist, then we return false. So one approach is, if you just ignore this last line, just forget about the time complexity for the time being. So one approach is we will just run two loops, uh, two for loops, because we have to check each and every element. So we will check this, we will check this, we will check this, and we will scan all the elements. If we found if any element is equal to our target, then we are going to return true. Otherwise, we are going to return false. So that is the first common approach which come in our mind, right? But they said you must write a solution in m cross n. Okay. Along with that, they have given such some properties. Some properties. So if you just look at these properties, we need to search some element, right? And they said each row is sorted in increasing order. So if we have some list like 1, 2, 3, 4, 5, 6, 7, 8, right? So if we have some list and we know the list is in the increasing order, and if we want to find some element, what is the best way to find that element? That is the binary search. So we can apply the binary search algorithm, because binary search is the log n algorithm. All right, so we come to the log n approach. Okay, but this is not a single list, because if we have the single array, then we can apply the binary search algorithm to search the element. But this is a 2D array, so we can consider. So what we have to do, we have to like apply the binary search algorithm in this row. We have to apply the binary search algorithm in this row. We have to apply the binary search algorithm in the third row. All right, and then if we found, then we return true. Otherwise, we are going to return false. Or what we can do is, before before searching, we can check each row. So let's go to the whiteboard. So this is our matrix. So this kind of matrix will be given list of list. So first list is the first row, second list is the second row, third list is the third row. All right. So first approach is, what we can do is we will scan all rows, right? We will scan all rows. As soon as we come to the first row, we will check. Let's suppose our target is 3. Our target is 3. So we will check whether 3 is, because instead of applying directly the binary search approach, right, what we can do is first check whether this 3 is greater than 1 and less than 7. Because if it is greater than 1 and less than 7, then it means it exists in this row. And then we can apply the binary search algorithm. If it doesn't exist in this row, we can go to the next row. There is no need to apply the binary search algorithm in this row. Then we will, let's suppose the element is 11, right? Or the element is 11. So what we can do is, if 11 is greater than 1, yes. If the 11 is less than 7, no. So it means 11 doesn't exist in the row 1. So we are not going to apply the binary search algorithm in the row 1. So now the row 2. If 11 is greater than 10, greater than or equal to, you can say greater than equal to 10, yes. If it is less than equal to or less than and equal to 20, yes. So it means 11 reside in this row. So we are going to apply the binary search algorithm in this row. Then we are going to find the algorithm. So instead of, so one approach is you can apply the binary search algorithm, unnecessary binary search algorithm in all the row. And when we know, because if you see the second property, the first integer of each row is greater than the last integer of the previous row. So you will not get the elements like this. So you will not get the elements like this. Maybe let me type. So you are not going to get 10, 12, 13, 14 in first row, and 1, 2, 3, 4 in second row. So you will not get, because they said the first element of each row is greater than the last element of the previous row. So this property violates. So that's why you will if we see the second property, the first integer of each row is greater than the last integer of the previous row. Right. So let's try this algorithm. Let me erase this. Where is the robot? Let me erase this. So let's try this algorithm. So what we have to do is we have to go for all rows. So how to scan all rows just by for loop. So till how many rows, that is the how many number of list within the matrix, or you can say the length of the matrix. So how many number of rows, n is equal to length of matrix. So this is number of rows. Okay. So we have, so one second. So we have one, two, three rows, right? So n is equal to length of matrix. Okay, so we have to search for all the, so for row in range of n. Okay, so what we are doing is we are searching for all rows. All right. Okay. Now we are on the first row. So we are on the first row. Shall we directly apply the binary algorithm in this? No. First, we will check whether the target is exist in this row or not. If the target exists in this row, then we are going to apply the binary algorithm. So in our case, let's suppose, so in this example, target is 3. So I forgot to write here. So target is equal to 3. Okay, so this is our target. Right. So now we have to check whether the target resides in this row or not, because right now we are scanning all the rows. So we are on the first row. So we are on this row where I put the arrow 1357. So now I have to check whether 1357 exists in this row or not. So how to check? Because we don't need to scan each and element. If we scan each and every element, then it's again m cross n. What we have to do is we will just, because we know it's increasing order, so we will compare the first element and the last element. So let's check. So if target is target should be greater than equal to the first element. So matrix of, so how to access the elements? To access the element row and column, right? So row and column, we access like this only, right? Row and column. So row, we know which row. Column, we have to always scan the first column, because we have to always scan the first column. So first column is 0. If it is greater than, and target is less than equal to matrix of row and last column. So how to access the last column in a list? -1. All right. So if it is like this, what we have to do? We have to, so now let's suppose we have 3. So 3 is exist in this row. So our problem is now will become 1, 3, 5, 7. Our problem is not a 2D matrix. Our problem is just a single array. Now we can apply the binary search algorithm. And we know how to apply the binary search algorithm. We will take left, we will take right, then we will find the mid. Okay, let's do that. So left is equal to 0, right is equal to, what is the right? Number of columns. All right. So how many number of columns? M. Length of matrix of 0. So matrix of 0 means first element of matrix, and the length of the first element of the matrix, so 4. So, and right is equal to, so length is 4, so but index is 0, 1, 2, 3. So m minus 1, or you can say this is m number of row, this is n, and we can say is m, and this we can say n. So right is equal to n minus 1. Okay, now we have the left and right. We have to find the mid. We have to find the mid. How to find the mid? In the binary search, left plus right divided by 2. So here left is 0 and is 3. So 0 plus 3, 3. 3 divided by 2. So we will get like 1.5. So we will get 1. So mid is equal to this element 1. Okay. So we will get mid. So we will check if target is equal to, because we have to search right using our binary search algorithm. So our target is 3. So we have to search if target is equal to matrix of which row, because how to access the element? Row, column. We have to access this element. We know which row we are accessing, but which column? This is the column mid. So this is the column. So row of column like this. Sorry, mid. Okay. If it is equal to, then we just return true. It means we found the element. L if if target. Let's suppose our target is 5. Let's suppose our target is 5. So it means our target is greater than 3, or greater than, if target is greater than matrix of row and mid, then what we have to do? We have to shift our left pointer. We have to shift our left pointer. So left is equal to mid plus 1. So these are normal binary search algorithm, right? What we are doing is, so here, so in starting, left is this, right is this, and mid we found this. But let's suppose target is 5. So our left is this. We know mid is not. So now our left will be this, right will be this. Right. So left is equal to mid plus 1. Else else right is equal to, otherwise, if let's suppose if our element is target is 1. So left will be remain this, and right will also become this. So target right is equal to mid minus 1. Right. So we will find the element like this, and after that we will return false. If our element did not find, let's suppose there is any element. Let's suppose our target is 13. So 13 is not in that row. So we will check all rows, and 13 exists in 10 to 20, but we could not find. So we could not find, we have to return false. So let's try to run it. So our sample case has been accepted. So let's try to submit. So something is wrong. So 111 test case has been passed. 133 test. Something is wrong. Let's see what is wrong. Maybe greater than or equal to. Mhm. Something is wrong. We are scanning for all the rows. So number of rows is this. We will check if target is greater than this 0 and less than this 7. If target is greater than and equal to, and target is less than this one, then what we will do is we will apply the binary search algorithm in this. Then left is 0, right is equal to n minus 1, n is equal to number of columns, that is 4, 4 minus 1, 3, and mid is equal to, okay. So here what we have to do is, we forget, we have to apply the while loop. While left less than equal to right. Right, because otherwise this is just only like one loop. So let's try to submit. Some syntax error. Okay, I forgot that. So you could see our solution has been accepted, and we beat 78% of the people in runtime and 9% in bounty. But our solution has been accepted, and all the test case has been run. But if you see here, wrong answer. If you see here, they have mentioned you have to do the solution in log of m cross n, but is our solution is log of m cross n? So let's check. So we are applying the binary search in the row. So which means so log of n, which is fine. But we are checking for all rows, so which means m log n. So our solution is not log m cross n, but our solution is m cross log n. Right, so our solution is m cross log n. So let's try to improve our solution, even though it has been accepted by the Leetcode, but whatever has been asked in the question, we will apply that. So what we have to do is, so this question, this solution has been accepted. So let's what we can do is, let's comment this. Let's comment this, and let's try the another solution. Let's try the another solution. Okay, so let's try another solution. So how we can, what we can do is, so if you noticed here, so what is causing the problem? So so our solution is we are scanning for all the rows, but here it is log n. So log n is not causing the solution. This m is causing the solution. M is creating the problem, right? So log n is not creating a problem because we are applying the binary search. So binary search is the best search algorithm, not the best search, but we are applying the binary search. So which is being expected. So log n, log m star and log m plus log n. So log n is fine, but this is creating the issue because we are checking for all the rows. But we know, so can we apply the binary search algorithm in the rows as well? So instead of scanning from first row, then second row, then third row, can we do something like that? Can we start from the middle? Can we start from the middle? Same as the search algorithm. Let's suppose we are searching our element in this. Are we starting from the start? 1, 3, 5, 7? No, we are starting from the middle, and then we are checking whether we have to go left or whether we have to go to right. So can we do something like that to find the number, to find the row in which our element exists? So the answer is yes. But so what we have to do is, we will start from the middle, and then we will check. We have to go above. So our element resides in the above row, our element resides in the middle row, or our element resides in the like below row. So we are dividing our problem into half. So that will be log m. All right. So to do that, what we have to do is we have to, because if we are like searching in the row, but we are taking left element, we are taking right element, we are finding mid, and we are scanning. But if we have to go up and down, we have to take top, we have to take bottom, and then we have to again find the mid. Same the like binary search algorithm. So let's try. So what we have to do is, so same number of rows. So number of rows m is equal to length of matrix and number. So this is a number of rows, and length of matrix of 0. That is the first element. So this is the number of columns. Now we will not apply this for loop. We will not apply this for loop, because if we apply the for loop, it means we are scanning all the rows. But we have to apply the binary search algorithm. So to apply the binary search algorithm, we need the top and the bottom. Okay, so what is the top? So top we will take 0. What is the bottom? So bottom is equal to, what is the bottom? Whatever the number of rows, whatever the number of rows. So whatever the number of rows, m. So m minus 1, because number of rows is equal to 1, 2, 3. But in index wise, this is 0, this is 1, this is 2, this is 2. So bottom is m minus 1. Okay. Now what we have to do is, again, like we will how we are applying the binary search algorithm. We are applying in this way. Same way we have to apply this. So we are doing by left less than equal to right. So what we are doing is, so here first we find the row in which our element resides or exists. All right. So while top less than equal to bottom. All right, because same thing, because if we have to do in this direction, then we do left right and then we will do mid. But if we have to go up and down, then we have to do top and bottom. So we have to do while top less than equal to bottom. Okay, now we have top and bottom. Let's find the mid. But in this case, instead of mid, we can call it as a row, because we have to find a row. or you can say called as a mid. So what is how to find? So top plus bottom divided by 2. So let me go through that. So in our case, top is 0, bottom is 2. So mid is like 2 plus 0 divided by 2, and we will get 1. So we will get this row. So we will get this row. So we will check, will our element exist in this row? So how we will check? So we have to find this element. We have to find uh, we have to find this element, right? So we have to check whether our element exists in this row. Okay. So if if target if target is greater than this 20, if target is greater than this 20, it means our element doesn't exist in top rows, our element exists in the bottom rows. All right. So let's check. If target is greater than matrix of matrix of so we find the row, because we already find the row. So row is this, but last element. So if target is greater than last, it means if target is greater than 20, if target is greater than this, it means we have to shift our top. We have to shift our top, because we are not going to check. Same as we have left, right. So we have left, we have right here. Right. So if we found mid, and if we found our element exists in this side, then we shift our left, right. So it's similar, same case here. We have to shift our top here. So top is equal to row plus 1, or you can say mid plus 1. Okay. And if target, okay, so we have checked whether our target is greater than 20. If target is greater than 20, all right, so if target is greater than 20, it means our element exists in the bottom row. But if target is less than 10, like in our case target is 3, so it is not uh, exist in the below rows, but it exists in the above rows. If target is less than 10, then it exists in the above rows. So we have to check if target is less than matrix of a row column. So we already know the row by finding this element, and column is 0. Column is 0 because we have to check in 0. So if it is less than, it means our element exists in above row. So top will remain same. So we have the bottom, we have the mid. So we have the mid. So what we will do is, so now our bottom is equal to row minus 1, or you can say mid minus 1. Else, else break, else break. It means we found the row, because we have to find the row. Let's suppose our target is 611. So, so our target is greater than 20. No. Our target is less than 10. No. It means our target exists in this row. So we found the row. So we found the row. Okay, so that's why we are breaking. So this logic is just to find the row. So instead of searching for all the rows, we are breaking down our problem to find the row. Okay, once we have the row, now we apply binary search on that row, on that row, right? Okay, so we have the row, but where is the row? So row is top plus bottom divided by 2. But it could, let's suppose our target is 13. Still we have the row, still we have the row, all right, still we have the row, but our element doesn't exist. All right. So what we have to do, binary search, apply binary search on that row. So we have a row is equal to top plus bottom divided by 2. Sorry, we have the row. Now we have to apply the binary search algorithm on that row. So left is equal to 0, right is equal to number of columns n minus 1, then while, then we are going to apply the same logic. Let me copy paste just. So let me copy paste. So we are going to apply the same logic. Sorry. So while left is equal to less than right, and we are going to return true. If element doesn't found, then we will return we will return false. We will return false. But I think there should be one more if condition. Let's try that, run that. So our sample case has been accepted. Let's try to submit. So you could see now our sample case has been accepted. So we beat now 84%, and memory also like 70, 70.87. So this is like even more efficient solution. So this is our like more even efficient solution. All right. So we did the both the ways. So what we do, okay, let's just revise that. So what we did is, so one approach is search for all the elements. That is m cross n. But in the question they have mentioned, we have to do log m cross n, and we know the rows are sorted, because if they did not give these two properties now, if they did not give these two properties, then we can search for all the elements just by running two for loops. But they gave these two properties. So we know if we have to search something and the array is sorted, then immediately binary search algorithm come into our approach. But we have to apply the binary search algorithm in each row. So instead of applying the in each row, what we can do is, so instead of directly applying in each row, what we can do is, we can like first check whether the element actually exists in this row or not. So we will scan all rows, or let's scan this row. So we'll check, okay, whether element lies in this or not, whether element lies in this row or not. So whatever, if the element exists uh, in the particular range, then we are applying the binary search algorithm. The same thing we will do in our first logic. So we will search for all the rows, and then we will check if that target exists in the particular row. Then we will apply. Otherwise, we will do nothing. We will check for the another row. All right. So now, but this solution is m cross log n. We have to do log m star n. So instead of searching for all the rows, can we apply the binary search algorithm? Because there is a second property. The first integer of each row is greater than the last integer. So these are sorted. So these are also sorted. So the same thing we will do. We will take top, we will take bottom. So we will first search for the row. Once we have the row, then we are going to apply. So in this, because this is very small matrix, 3 cross 3, then you are maybe saying there is no much impact. But if you see the length, so length is 100, because if there are 100 rows, right, then the matrix is very large. So if we have to divide in 50 and then divide by 25, then divide by 12, then our search is even more smaller. Instead of searching all the 100 rows, we have to search only 50 rows, and instead of searching 50 rows, we have to search only 25 rows. All right. So we apply the binary search algorithm to find the row as well, and we have to apply the binary search algorithm to find the integer as well. So that's it. That's the end of the video. So we did both the ways. So you can also try this question. This is a like good question. So thank you.